Lady, what is this?
Hey, everybody, and welcome to Show and Tell. It's me, Lady Ada, with me, Mr. Lady Ada. We're here in the Adafruit remote headquarters, and we're going to be doing a 30-minute show and tell with people from around the maker community to see what they're up to, what are they making in 3D printing and turning into drone synths and more. We've got a bunch of people from the Adafruit engineering club here.
It's also everyone's chance to meet some of the people who probably write the code or make the projects that a lot of you use. Sometimes you just see a name on a guide.
Or commit. Who is that person?
Yeah, how did this get here?
How lovely are they?
Yeah.
We're going to find out.
And, a lot of the code that runs a lot of the projects out there, some of the people here. Retsa, say hello. Let's start off with Jepler.
Yes, but other people are welcome. Come by Discord.
Yeah, we have the link in Discord.
The link to Discord. Link to the whereby in Discord.
What you doing?
Hey there.
What's new, Jepler? So
this is the, I won't get the name right. It's the USB host feather wing or something along those lines with the Feather RP2040.
Wings go on top.
It's a feather, not a feather wing, because it's like running Circuit Python and everything in this case. And yeah, so I've got a wireless keyboard plugged in to it. And if you bring my screen share back, I'll show you what I'm working on. So Scott loves to create different workflows for CircuitPython. We have the original with the USB with the CircuitPy drive and Bluetooth and Wi-Fi. And so we're kicking around the idea of what if there was a workflow that didn't require a computer at all? So I've got here the wireless keyboard that goes with it that's plugged in, and I'm showing the serial terminal on my computer. But imagine this is like a display IO TFT, or maybe you're using another coprocessor board to make it DVI. And so I can go in and open up one of the Python files on my disk and scroll through it just like a text editor. This is like Nano, but even more basic. So like if I didn't like this line, I could comment it out. And then when I'm done, I can go back to my file chooser. And so I have to give a shout out to somebody on GitHub, Wasim Lorgat, who is CM on GitHub. They wrote this text editor in just like a few pages of Python code. And it uses the standard library called curses to talk to the terminal. And I implemented a version of it called Dang that talks to the CircuitPython terminal using ANSI escape codes. And anyway, so that's what I'm up to someday.
And like Dang is just a lightweight curse.
Right. That's kind of the idea. Yeah. Everybody, like I found somebody who called their version cuss, and it's like, you got to have a cute name because curses is a cute name.
Yeah.
But yeah, so it's like a screen editor in about 6 pages of code that does all the basics. And, maybe we'll elaborate on it, or maybe we'll just say, here you go. But someday, CircuitPython without a host computer to edit and run your Python scripts. And
I like how we're getting close to the goal, which is the Cocoa 2 or Apple 2GS of embedded microcontrollers is coming.
Yeah. I was kind of inspired to do this by my Run CPM project, which was recent, that created a vintage emulated system with a keyboard and a display built in and no host computer. And it's like, well, that would be even better with CircuitPython because you'd rather write Python code than Z80 assembler by a long shot.
Yeah, one of the goals, we were talking about this on another show, is starting off with like a CircuitPython powered ruler and then working your way up to like a calculator or like a little keyboard and then eventually a full-blown standalone computer. But you need tools to do some editing and code, and eventually it'd be nice to not have a computer connect at all. So this is one step closer. Dang, this is a cool project.
Can I put in one request, Jepler, just because I know that this has always bitten me? Can you have tabs displayed with like maybe a little arrow key or something?
I don't know about that. I mean, we're a little limited in terms of what the display IO terminal can do. So like there's no ability to show a faint arrow, but we'll maybe figure out something because the other thing it might do is just not let you type in tab characters ever at all.
Okay. Dang.
I sure didn't test that. It might not work.
Don't. All right. Okay. Well, thank you so much. That was a cool project.
Have a good night. Thanks for this. I'm so excited about this board because we're going to do so many things with it. And
this is a huge collaborative effort. I mean, like almost everybody on the Adafruit team, is making this happen. And I was excited to. The funny is, the USB host stuff originally, I kind of pushed for it to be ported to the RP2040 Yes, to do it in CircuitPython, but I really need it for my tester boards because the TNC 3.6 is basically just
we couldn't get any, and we were using it for all of our testers for a long time. We're like, what are we gonna do?
So I was like, I need another device that has built-in USB host, and it's inexpensive and is durable. And so the RB2040 chip was kind of the only thing available, and that's what kind of made me like excited when I saw the PIO port of USB host. So it's like, we do things for internal uses, but then that work ends up kind of trickling down into the general computing.
And it must be pretty robust in practice if it's good enough for the testers.
I mean, I really and the thing is, we got so many bugs. So it's like, okay, I'm testing it against so many different chipsets and mass storage we got working, and CDC obviously, and HID. So it's kind of neat. It's like something that I want ends up being something that other people want most of the time.
Yeah, we would love to add all those things into CircuitPython, but it'll take a while. We'll see how that goes.
I can't wait.
That'll be CircuitPython 9, maybe about USB. I don't know.
Yeah, maybe. I mean, what we should really do is get it working with those USB floppy drives, and we'll be able to load CircuitPython.
Load my CircuitPython code from a floppy would be kind of cool. All right. Well, I'll let you get on to other folks, but good to hang out with you a bit tonight.
Thanks,
all right, thanks, Jepler. All right, next up, speaking of Scott,
what you got going on?
I'm so excited about what Jeff is working on, let me tell you. So I'm also working on USB host, and I think I showed it last week that I'm working on the IntelliKeys. And I was just getting my demo going, and I got this crash. So I thought I'd show the crash instead of just showing it working. But what has happened here is that there's some assert deep in the C code of CircuitPython that's been violated and completely halted my demo. But what I was going to show is that, and when you and I had talked about this, is that we were, you said it was hard to do the IntelliKeys because it re-enumerates. So the IntelliKeys doesn't store its firmware. You load it every time that you talk to it. So here what you can see is that we find the device with the PID where it hasn't been loaded, and we successfully load it. And then I just there's a sleep here that's 2 seconds. And then when I list the devices again, it comes up, and it did work. So if I scroll up, you can see that what I was playing with was reading just some string descriptors. So using a USB control call to read the string descriptors. So we can see both the manufacturer and the product name here that's being read from CircuitPython. And one kind of neat thing is the way that the code is written is it does the list, and then it sees if it needs to load the firmware or if it doesn't. So you can actually see here that we saw that we didn't need to load the firmware again, so we didn't. And so if we have time, I'm just going to unplug it and plug it back in and see what happens.
Okay.
And how's the speed? Because I know you were working on.
It's pretty quick now.
Okay.
And I hit the failure again. You know what?
It did re-enumerate.
Okay, that's good to know though, because I was just trying to. I crashed it hard. Anyway, I have an idea what it is, because I was adding a third descriptor load that was the actual device descriptor, and I must be causing an error that I've not caused before.
Yeah.
And now I'm getting this assertion failure. So I'm working on that. And I'm excited to see that it does work with the re-enumeration of the IntelliKeys.
Okay, cool.
All right, and then before we go, special thanks to Scott had recommended this kid toy like a month after we had a kid, and I found the email, and I'm like, this is cool. Why aren't we hacking this and turning this into something with Wi-Fi and CircuitPython and music? So we're going to show this off on Ask an Engineer tonight, but door to door, about 6 months. I have a green screen, so it's on. Yeah, Hollow Man. Right. This is a Wi-Fi enabled kid toy. You can put new songs on it, and we think this is going to be a fun development board. So kind of neat to see all of our creations go into different places, different form factors, different things.
Yeah.
So,
and gotta thank my sister.
In different places.
Yeah, the web workflow is gonna get some polish.
Yeah,
but thanks to my sister who got that toy for Ari, my kid.
Apparently these are standard issue. I was talking to someone, they're like, "Oh, I have 2 of these. I don't know where they came from."
Yeah, they're a common. a baby shower.
So the
gift,
first
'cause they're
thing,
$10.
the first thing is, oh wow, I have those. By the way, do you know any way to change the sounds? So we'll see how it goes. Okay.
I was happy there was 2 volume levels.
There is. We kept that.
Yeah.
Sweet.
Yeah. Okay. All right. Thanks, Scott.
Thank you.
All right, JP, what you got going on?
Hey, it is Blade Runner time here is what I've got going
It's always
on.
Blade Runner time. And it's time to put up Halloween decorations.
That's right. We're ready. So a lot of you recognize this is the giant building, the Tyrell building from Blade Runner. And what I did was we had this idea of taking a dystopian drone synth that Todd Kurt had designed, had written the code for in Circuit Python using synth.io to just create these big sort of detuned, fat-sounding synth pads, reminiscent of Blade Runner and other soundtracks of that era, and design it inside of an enclosure that is based on the Tyrell building. So I got excited about this on Monday. I just gotten back from vacation, so I built this model to house it inside of Rhino, 3D printed it out, and I have a second version in the works right now. But what I've done is I've added some copper strips right now to act as capacitive touchpads to adjust parameters of the synth. So what I'll do is I'm going to turn up the volume so you can hear it. I have it plugged into some powered speakers, and I can show you what it's running on underneath. And when I hit the copper pads, it'll adjust the transposition of the keys that it's playing.
You should take up vaping and like blow some smoke into it and like listen.
We should just wait till the wildfires start hitting California. And
You could
then
do
take
like
it
a very
outside.
cool mini movie with this.
Yeah, I like the. I brought in some extra little lighting on the side here, so we could do
Is
some.
that Blade Runner for ants? Okay.
That's my iPhone as the one.
Yeah.
That looks great.
This is
Yeah,
really
I
cool.
love it.
Yeah, you should put an iPhone on like a little Hot Wheels or something and just like
Yes.
roll it forward and like do your own little.
Truck in on it. So there you can see, I'll show this on my show tomorrow in more depth, but I've got a little circuit here using a QT Py and our little TRS S breakout, all happening inside of CircuitPython synth.io, which is kind of mind-blowing. And I was even able to use, I've used just about every pin. I think I have a spare or two, but I've got 8 of those acting as capacitive touch. And I've got plans. Right now, they're all doing the exact same thing, but I've got some plans for little pairs of these that'll adjust synth parameters.
This is cool. All right, thanks so much, JP. See you
Sure
tomorrow
thing.
on your show.
Yeah, come on by.
Okay, we're gonna go to Erin, and then we're gonna go to Liz, then Mouse and Tim, and then Brennan, and then Andrew. So we got a full house tonight, so we'll try to move along as quickly as we can. Erin, what's going on?
Really quick. So I've just been working on this dress, which is built on the Oozemaster 3000 code. I'm going to back up a little so you can kind of see.
Oh, neat.
And right now it has a bunch of lights in it, obviously, that are running 7 different drips all around the dress. Eventually, it's also going to have a little drip splat at the bottom so that the drips actually are going to land. It's a really cool code. It's built on Phil B's Oozemaster 3000 code, which he's been using for Halloween projects and dripping skulls and oozes and stuff like that. And I wanted to make something real elegant with it. And I think I succeeded.
I love this.
This is great.
And then I got a button right over here where if I hit it, then it will go into carry mode where it suddenly starts dripping blood everywhere, which is
Here, let me go back here.
So yeah, I'm working on this and I am writing it up this week. So I'm going to have a kind of just a high level tutorial about how I made this up in the Adafruit learning system.
If you remember, can you send me a TikTok formatted video for, there's always the TikToks like, what's the fit? And like, you kind of like do the little
NeoPixels.
Yeah. If you remember, it'd be kind of cool.
Absolutely.
Well, it looks great. I love how it's like a little bit of a joke on the wet look. There's like wet look dresses. So it's kind of funny. It's like, okay, this is wet look.
Someone's going to make one of these and go to that cool giant Las Vegas LED ball and stand in front, like you have to matchy now. Building has to be
the one
LEDs.
to do that. So.
Yeah, and then building has to be LEDs and dress has to be LEDs. Okay, thanks, Erin.
Thanks,
All right,
Erin.
thanks so much.
All right, Liz, what you got going on?
Hello. I have something super simple and quick. So I've been working on the quad rotary encoder breakout, and it has a neopixel underneath, but the clear rotary encoder is really hard to find. So I just 3D printed a little kind of riser for the encoder so that they can still solder in, and then you can still diffuse the neopixels so you can see all the colors still. So when I work on a project with it, still be able to see the colors. So just a quick little thing.
Yeah, we just got these in the store too. So
Genius.
Yeah.
I know. I gotta find those clearing shafts.
Look at that.
It's a bit of a thing. But
Oh
we
yeah,
will eventually
totally. So this is like a little like
a good
bridge.
intermediary hack.
Yes, yeah. So
All
I'll
right.
share the model up if folks are interested for their own.
Thanks, Liz.
So
All right, thank you.
Okay, a bunch of
Liz.
folks came in
Okay,
after we got
good.
started. So Mouse,
Show off your
what
rack.
you got going on? Whoops,
Wait,
that's
that's
Tim.
Hold on.
I'm getting
All right.
it.
Hello. Okay, I'm going to play something on my synth to see if you can hear it. Does that come through?
Yeah.
Okay.
We'll bop it.
So this is my modular synth I've been working on for a long time. A little while ago, I showed off a prototype of a digital FM module based on a Feather RP2040, and I have the final sort of hardware here. It can do different sounds.
You've got the light up cables. too.
I got one of Liz's glowy patch cables there.
That's cool.
So I'm going to show you the hardware. Just a sec.
Do you want me to take the screen off and just go to the?
Yeah.
Cool.
Yeah. The screen is my patch editing software, which I probably won't show because you've got a lot of people on today.
We'll come back next week. We're around.
Okay, yeah, I'll show it up next time.
Yeah.
Okay,
Show
so
the hardware.
this is, there we go. So I ended up using a keyboard instead of a Feather because it's smaller, and just a couple op amps and a D-to-A converter, and I've got all the controls mounted here. The USB connection's a bit janky because I didn't know if I could. I didn't put it on the front panel because I didn't know if I could run the USB signals through these through a regular header connector. So I just put a little right angle thingy on the thing.
Yeah.
Yeah, and so I've been working. I've been working on it for a long time, and it's still not entirely finished, but it's getting to the point where it might almost be done. So
This is great.
Yay.
Would you
Oh,
mind
that's an animation
around to the end of the show and play us out with some music?
Okay.
Okay, so we'll keep going, and then come back and show the interface. We're here every week, but
Yeah.
if you don't mind, stick around because sometimes we have a musical guest to play us out. So
Okay.
okay, all right, Mouse. We'll see you in just a few moments. All right, Tim, how's it going, Tim?
Hello, I'm very good, thank you. I have two things I'll show real quick. One of them is a preview for some upcoming stuff that I've been working on that I want to do for some text embellishments. So I have 3 rows of text here. The bottom 2 are the 2 that you can do easily today with the display text library. And then the top one is the one that I've been tinkering on. And I have a PR with some bitmap manipulation over in the core that makes it nice and fast. And this gives us the ability to make a bitmap dilate or grow a little bit, or I should say a shape within a bitmap. And then in this case, we can make it grow and then change the color of the part that has grown so that it will look like an outline. And we can, of course, do that around text. So we can have custom text with outline colors. Right now, it's pretty gnarly. It's all just hard-coded in this super high-level function that's just kind of doing everything. But I am definitely planning to try to make it easy to reuse and make a special new type of label so that other people can do this and set it up much easier than the code that I have with it right now. So that's the first thing. Keep an eye out on the display text library for that if you're interested. And then the other one is a super quick one that I'll just show the demo of real fast. For the 4th of July here in the US, I was just playing with the Matrix portal a bit. And I whipped up this little sort of firework animation where it just draws a couple of bitmap pixels and then animates it to do this little explosion effect here. So
That's cute.
Oh, cool.
not too much on it, but that was something that I was hacking around with on the 4th yesterday, which was fun. So I thought I'd try that too.
All right. Thank you so much, Tim. For folks who want to tune in, so every Friday there's a deep dive, and then you sometimes do a weekend thing. They're fantastic. Yep. I put them on in the background and listen and watch as I'm doing other things, because the innards of CircuitPython, it's literally a deep dive. Yep. So that's coming up this Friday, 3 p.m. Pacific, 5 p.m. Eastern, and then you also have I think it's every couple of weeks at CircuitPython.
Saturday mornings, I usually stream as well. Yep, you can find that on the Discord as well. If you hit up the live broadcast channel, I post links in there when I get going on the weekends.
All right. Okay, well, thank you so much, Sam. That's very cool.
For sure. Yep, thank you. See ya.
All right. Next up, we're going to go to Brandon, then Andrew, then we're going to have Mouse play us out. Brandon, how are you doing?
I'm doing well. I'm doing a lot of color these days.
Oh, that's great.
That I'm not talking about color tonight. It's really interesting that your rotary encoder, the idea of 3D printing an element on it. Last weekend, I laser cut this little disc for the exact same purpose.
Ooh.
And so it's 2 millimeters thick, and it actually works pretty well. Though, Lady Ada, I do have a beat on rotary encoders with clear shaft for underlight, but I can't find one that also has a push button. So it's either an either or.
Top ones they don't have a switch, but also top is incredibly hard to get them to sell me stuff. They just kind of don't reply to emails.
Well, I've got 1,000 coming in, so we can. So what all of these items are, it's sort of like Seesaw on steroids. So these are all I2C user interface devices, but instead of having a low-level interface, they all have a very high-level interface. So like this one over here is neopixels, but you can configure it with various colors, and then it just takes 2 values, and you can set if you want to use it for VU type things, you can have an attack decay. So like if I give this, see, it'll and it kind of zooms in and zooms out.
Yeah.
And then I can also control what color it is, so I can make it any color I want, or I can go back to VU mode. So that's a pair of, it's 20 LEDs. And it just, like I said, once you've sent it a couple of commands to configure it, you send it just 2 values. All I have to do, every time you send it 2 values, it just updates.
Neat.
The next one over is 2 touch devices. So this is a touch circle. And so it gives you a continuous value, even though it's a touch. It'll give you a continuous value between 0 and 255 or 0 and 360, whatever you want to set it up for. And then the top one gives you an X and a Y. And again, it gives you continuous values. So this uses 3 touch sensors that are all interwoven. And this one uses 6 across and 6 down that are all interwoven. And so you can get all sorts of really interesting value data out of that one. Rotary encoder, you probably have figured that one out already. And then, of course, the keypad. And the keypad outputs the exact same thing that the keyboard or keypad from CircuitPython does. So it just simply outputs a key value and a press or a release. And you can set colors for the buttons if you want, or you can just set them all the same. I've got the bottom row at red. And then the top ones are displays, and they support a few different modes. So this is a menu mode. And so while it's in menu mode, it's actually not sending any data back and forth to the host. But when you hit the select button, it records that, and then the host can simply say, "What's the current selected menu item?" And it'll give you that information back. So it'll do all that on its own. And then the bar graph one you can see here, it just simply takes a bar number and a value, and it will reset itself and just keeps painting it. So again, all you're doing in the bar graph is you're sending it bar number 2, a value of 100, bar number 1, and so. It's really, really responsive, and it looks really kind of cool, but there's not a lot of data going over I2C. So, and like,
yeah, nice work with this stuff.
And as you probably can tell, they're all using an AT-Tiny 1616.
Yeah. It's available. You can buy it. And it's like the core for the Arduino core, which is what I'm using, works very well. And like, the I2C controller peripheral code works great for it. And I've had, I mean, it's, you want to run it at 20 megahertz, but it's, I've really enjoyed porting all the SAMD09 stuff to this chip, which is 3 or 5 volt compatible and, has good support and is purchasable.
Yep. I actually went a slightly different route. So you may remember I talked about the little AC1, which is an AVR programming module for a programming course, and it teaches basic AVR programming with just the AVR register code and stuff like that. All of this is the 102 level course. And so the advantage is like the rotary encoder, it's like 3K of firmware.
Yeah.
The touch panel is like 2.5. The neopixel is like 3K of firmware. The only one that's really big is the display because of the graphics drivers and all the text and buffering that it does. That's 7.5K.
Yeah. Look, hey, I've got 16K of space available, so I'm lazy.
Yeah, I know. I'm not worried about 16K either. It's it's pretty fun.
Keep coming back as this evolves. I know, we see this on the socials too. If you want to put a link in Discord to where people can find out more, but I know you're still working on this. Come back and
this is cool. Love it.
And show it as you continue to work on it.
Yeah, tons of documentation, because that's the thing, that to make this stuff really usable and people to understand not only the code side but then the usage side of it. It all has a lot of documentation. So that's my big thing right now.
All right. Well, thank you so much.
All right. Thank
Cool.
you. Keep
All right. We're going to go to Andrew, and then Mouse is going to play us out. Andrew, what you got going on?
Hey, hi. I got an E.ink, the 2.9 inch, and I've got it hooked up with an ESP32 S2 doing environmental sensing. I've got an SED40, so the CO2 level is the big number. And then I've got the BMP 280, so that's doing the temperature and humidity. Pulling out a requests call to doing a little XML parsing to get the little numbers, which are the outdoor temperature.
Yeah.
I can see you're high up. Are you really 700 meters above sea level?
Yeah, I'm in the mountains. So
that mountain is behind you. It's true.
This is real.
Yeah. Actually, and the one cool thing is that I actually had my very first pull request merged into the BMP 280 library.
Yay.
So thank you to Carter Nelson. I added the ability to add a altitude setter. So I can just say I'm 700 meters, and then all of the calculations for the changes in barometric pressure get actually changed not in altitude, but actually into actual barometric pressure. So that's what I'm working on. It's got a little 150 using Deep Sleep. I learned tons of display I/O, the bounding box.
That's great.
This is extremely useful.
Yeah, I had a little graphics
in the window though. 800 is kind of high.
It is actually, and outside it'll only go as low as about 600 up here. So
you probably need to recalibrate it then. There's a calibration for the SC. Well, the SCD30 doesn't recalibrate. It should be 400 outside unless there's something really weird going on.
It also has a altitude setter as well. So the SC.
Oh yeah,
I'm setting that as well. But anyway, I just wanted to show that off. That's kind of what I'm doodling on. And
this is really cool. Congrats on your pull request and everything.
Yay!
You can make a display that has your number of GitHub stars and pull requests.
That's next step.
All right, thanks, Andrew.
All right,
thank you very much.
And
all
just
right.
in time, it's 8 o'clock.
Our house band is here, and Mouse plays out.
Mouse it out.
Yay! All right, thank you so much, Mouse. That was perfect. All right, thank you so much, everyone. 8 o'clock on the dot. We'll see everybody next week, 7:30 p.m. Eastern time, every single Wednesday, showing and share your projects. Thanks for making this the best half an hour of our week. Every single week, Ask an Engineer starts as soon as I can press all the buttons. See you in a moment. Bye, everybody.